Good afternoon everyone, and thank you very much for joining us. I'm Emily Priest and I'm here with my colleague Andrew Hanson, and welcome to today's webinar showing how you can manage your engineering bill of materials in PTC Windchill. For some background, Concurrent Engineering are one of the PTC resellers within the UK, providing solutions for CAD, PLM, technical documentation and the Internet of Things. There's more information on all of these solutions on our website, and you can also find our list of upcoming and on-demand webinars and instructions on how to register. We like to keep you informed, so if you don't already, take a look and connect with us on one of our social media platforms. Follow our YouTube, LinkedIn, Instagram, Facebook, Twitter or our blog, where we let you know about upcoming offers, new releases and keep you up to date with any company news. So today we will be taking you through how managing your bill of materials and adopting a part-centric approach can help you reduce duplicated data, support design change and eliminate disconnected systems. The webinar is being recorded and a link will be sent to you later on this week. I will now hand over to Andrew, who will be taking you through the presentation.
Yeah, thank you for that, Emily, there, and good afternoon, everyone. So thank you for joining. So as Emily said, today we're going to talk about managing your engineering bill of materials. So when we're talking about engineering bill of materials, for those of our Windchill customers out there who are not using Windchill for managing your engineering bill of materials, also known as your EBOM today, some of these may be familiar to you as examples of how you might be managing the definition of your engineering data, whether it be by just currently managing your CAD data and its structure in Windchill PDM, or by an ERP system linked with manual or homegrown legacy solutions with the transferring of information. The latter usually compromising of spreadsheets, which can be done informally in the managing of your descriptive engineering information, or by drawings where the engineering BOM is defined and then manually entered into the ERP system. There can also be links to various different silos of information that might be out there. So some examples we can look at how companies today are working. CAD doesn't provide a full definition of the bill of materials. There tends to be non-modelled information that exists that's relevant to the bill of materials. Supporting documentation such as material specifications and requirements, etc. are stored in other locations. We can also see is that information can be duplicated or repurposed by PDFs and copies sent to various different departments, whether it be in purchasing or in manufacturing. This can lead to a negative impact of data being unsecure and poor BOM accuracy. So that as well is keeping the bill of material and the drawing up to date with product development changes that occur. Designers have to communicate all that information. Updates to any of that product information requires updates to those drawings, and other people might need to be involved in decisions about them. BOM changes then require revisions to drawings. Drawings need to be resent to suppliers, although nothing has really changed in some instance on the face of the detail that's actually within that drawing itself. Current methods of managing your EBOM does not scale to the numbers of variants you might be looking to produce. Designers can sometimes find it difficult to reuse parts. There are a growing number of products that require a greater part management within that. So you have to ask yourself the questions is what to keep in an inventory, what is it that purchasing need, and how do you support customers and field requests? This can really help you look at the inventory costs and the number and costs of NPI and also prototypes that come into the business. Also, we can see when we're looking at this is that the time to manage change when a bill of material information is distributed, negatively impacting time to market. The cost of maintaining multiple systems from IT, the delays in the development of supporting documentation and any manufacturing plans when access to the bill of materials follows in the serial process. So whether we're looking again at design reviews or MPAs, some teams are unable to access that data and make quick and effective decisions in an informative way. So one thing that we talk about is moving from being a CAD-centric approach to talking about being a part-centric. And we're going to take you through an example here of a single change. So if you imagine I'm this person here and I've got a part that sits in the middle, the data that's actually associated with this, there could be a change request that comes in and gathers some information. Associated to that as well is this attributes, and this is all information that you would have defined somewhere within the business that is hanging off that particular object. We can also say is where is it used? And some of this you'll already be familiar with. What is the impact on cost if you have attributes associated to it? And the data expands. For those of you who are doing documents and data, they also have an impact of change and associated to that engineering bill of materials. What does the part actually look like? This is where most of you are at the moment. You have your CAD data, your drawings, you have your visualization, and they're in the various different environments. Other areas to look at as well is what software is affected within this area and any other changes that might be taking place in the background. And very quickly, this can expand into technical publications, requirements, manufacturing bills and materials, ERP information, and also packages. So by taking a part-centric approach, you are looking at the total data structure, not only of the upstream deliverables, but also the downstream deliverables and how they are all tied together. So clearly you can see from this picture is there is quite a lot of data that builds into that. So another way that we might take a looking at this is having a look at it from a foundation data example. So if we take a data management example, here we have in a particular layer data management. We're just managing the documents, the CAD models and the drawings, which are used to give you revision control, drawing approval and CAD data management. This gives you the single source of truth, your data under control, your auditability of being able to look at the history, and also repeatable processes for signing off. Now, if you can use that existing technology and expand upon it, but to actually start managing the actual bill of materials, or as we sometimes refer to it as the digital product, things like links, baselines, a view of the complete project, all that information is captured but tied into what we call parts or a bill of materials approach. Information is linked to a structure, and once you have a structure, this makes it easier for you to exchange that information with other systems using standard information transfer protocols. But this can then be taken even further because you could introduce a bill of materials. And this is where if you take a CAD structure approach versus a bill of materials approach, we can see how they can be linked together. So no additional rework is used as you can repurpose that existing set of data that you have within the system to build your bill of materials. And this goes even a step further. So your engineering bill of materials is just the start. Your CAD structure can define that. You can add additional pieces of information to it. But then where does it go from there? So this is the first stepping stone before starting to look at different variants of it, such as your manufacturing bill of materials or various different product configurations and instances. And the final goal is, can I get my engineering bill of materials correct that I might then want to be able to push and transfer into my ERP system? Likewise, there could be configurations where your ERP system would also be pulling information back into your engineering bill of materials. So a lot of information and a lot of links, and how do you maintain all that information from one part to another? So an approach that we like to take when looking at this is talking about your maturity levels. Some of you might be already familiar with these. An example is to ask yourself that question on this maturity level as we go through is, where are you today? Most of you on this call today, we'll say is that we're at level 1, is your CAD structure is being managed in Windchill. Your BOM might be in a different system, whether it is in Excel or in a homegrown system. The BOM actually might be on a drawing, a physical piece of paper that's moving around the shop floor. The CAD model is managed in PDM, and so is the structure of that, and you have them under revision control and access control, which gives you some great tools right there. But if we could have the possibility to expand that, and for example, start to manage the BOM. So let's take you up a level. So the bill of materials is now managed in the same system. A single source of truth managing your bill of materials and your CAD structure. This will save you having to rekey in information between systems, reducing error, and hence speeding up the transfer of information. The BOM can still be on the drawings, but it can also be in the PDM system as well. Both the CAD and the bill of material structures are under revision, change, and access control, giving you a wide variety of similar processes to manage all of the data that you might have. And the step above that is level 3. It's kind of where we say is you can then integrate all that with your ERP system, and there's no need for drawings in this instance. So we like to take people on a journey when talking about this. You can see the various different levels that are available to users out there, and how you can actually elevate yourself from managing just your CAD structure to actually linking it to the engineering bill of materials. And most of you will have this capability there all day already. So let's take a look at how we can do that within the software that you have available today. So here we can see we're in the familiar Windchill interface that most of you will be using. We can see here as I'm looking at a very simple CAD assembly. We're in the familiar data environment. So I'm going to take a look at the structure. In the instance for this, in my structure, as I can see, is I've got a set of information. I've got singular quantities, I've got numbers and versions. And this is today what a lot of you will be familiar with. Attributes being mapped in and that data there. But what can a bill of materials bring me that's above and beyond this? So using the links within this environment is I have the capability where this model actually has parts associated to it. So in my related objects, I can look at my where used, but I can also look at the part. And here I have this engineering bill of material part associated to it. I can go and look at the information behind this. So repurposing and reusing your existing data is really quick and simple. And one of the key concepts when we work with Windchill is we talk about visualization and collaboration. So as part of that, any visualization you have from your engineering CAD data is automatically mapped across and reused in your associated bill of materials. So if users have access to just bill of material information, they will only see this level of data that they need. But what's different and what's really powerful here is I can go and look at the structure. Now the structure here, as we can see, it's kind of linked up with these icons, but straight away it looks slightly different. The information is the same that's there. I can expand and I can drill down to see what's in those. And what's really powerful is I can go to my visualization. So here is I can switch on the visualization aspect of that. When I'm looking in this environment, you'll be familiar with Creo View. It's integrated in this really simple, quick to use interface. I have the same controls that will be familiar, and I can navigate and quickly see what's going on. If I select a component, it highlights it in my tree on the left-hand side. If I select a component in the structure, it highlights it in the model. So it's very quick and simple to interact. Where this expands upon for users is the ability to look at the uses. So if I've got a bill of materials, of data, I can actually start to see now very clearly here, what are my quantities? And more importantly, there's units associated with them. So for all of these, it's collecting them all together and it's interrogating it and it's building up that structure of information readily and easily for me to see it. So some great data there straight away. Now this bill of materials has been built from my CAD structure, but then there's additional information that needs to be added to it. So very quickly within this environment, I can say let's add an existing or new component to it. And this could be, in the instance of this, something like some grease or some paint that I might need to add. This gives me an interface for me to work through, and here I'm going to just quickly define this. So I'm going to give it some name, some grease, and I have some attributes that help me define what that engineering bill of material item is. And as you can see here, these familiar terms, source, default units, gathering parts, phantom manufacturing parts, a terminology that's also used in ERP systems, so this enables this information to be easily transferred to other areas within the business. I'm just going to fill in some of these informations really quickly. You buy this in this case it's measured in litres, and I'm just going to say finish. So I've created that part, and straight away here we can see it's added it to my actual bill of materials data. So this is where I'm turning into a more part-centric, and I now have a combined bill of materials that's updated to properly reflect what's going on in my actual model. I can go into this interface and I can actually update these values as I need fit. So in this case there's going to be 12 litres of grease. As with the familiar interface when working with this, is I have the standard control, so I'm just going to check that back in to say the job's all done with this one and add some comments. Very quick and simple to use, very easy, and from that I can then go and export it. So with this bill of materials, let's say I want to generate a report. Out of the box come a list of standard reports, whether it be a single level bill of materials right through to a multi-level. In this instance, I want to export that straight away as a bill of materials. Just going to authorize there with my username and password, and this is going to generate a standard out of the box report for me to actually work with and export. So here we can see is that report is being added in. I've got numbers and versions, information I want to see, and all this is configurable. With this data generated for the user who has access, they then have the capability, if they want to go and export this straight away into a variety of different formats that they can then repurpose further down within the business. So a great tool, easy to use, fantastic to easily adopt. So that was a quick technical demonstration of kind of how you can move from CAD structure to engineering bill of materials, how it's all within the same system, and how you can repurpose it. So one of the key things now is, how can this help you improve on what you're doing? So by adopting this, is the engineer, they can adopt the ability to standardize and automate on processes, use the out of the box and the existing processes that they have in place. This will enable you to give you a complete full product definition that is managed and stick to the story of a single source of information, whether it be requirements, CAD data, and your bill of materials. This will make it easier for other users within the business to find and reuse that rich source of information that you are designing in your CAD tool. It will improve the efficiency of your processes, and it will better enable you to make decisions that are right first time for what you're delivering on. So how can you get there? And there's many different future options. So if we take an example where within Windchill PDM Link today, you might still just be managing your CAD data. You might say, okay, I want to manage an independent engineering bill of materials. It might mimic the CAD structure, or it can be run independently to support other areas of the business and to help with adoption. There might be a partial associated EBOM, where some CAD data is associated and other data isn't. This is to help businesses build up the structure and the data model that is right-sized for your adoption. Now you can go for the fully associated EBOM, where what I define in my CAD fully defines what is actually in my bill of materials, and like you saw in my demonstration, potentially then go on further to add additional parts that aren't defined in the CAD environment. So PTC's engineering bill of material enables you to deliver that complete bill of materials. It still supports that multi-CAD data management, so not just from Creo, but also tying it into other tools that are out there, and also other ECAD authoring tools that can suddenly add to the bill of materials and give you a complete rich set of not only a mechanical, but an electrical bill of materials in one place. It adds to your search and where used capability, building upon the existing functionality that you may have, and the ability to export or import spreadsheets of that information very quickly for exchange in both upstream and downstream areas of the business. As you saw, visualization is key as well, and as that's a core concept, that carries through into sharing that information with other people within the business. Other areas which can open it up here we can see is the impacting of change and substitutes and options and variants, which shows you the system is powerful enough to grow and expand upon what you might have there already.
Thank you very much, Andrew, and thank you to everybody for joining us today. Hope you found this session valuable. You can stay informed, as mentioned, by subscribing to our blog or connecting with us on LinkedIn or Facebook, or simply keeping an eye on the website. We have got a few future webinars that are coming up. So on the 27th of June, we're looking at the all-new Creo manufacturing extensions. On the 18th of July, taking a look into AR and how that can help in field service and after sales. And then on the 19th of September, taking a look at smart connected products. So I'd like to thank you again for your participation in this session, and do enjoy the rest of your day.